All right, so this first one is just going to be linear. It's just your regular y equals mx plus b. So we're going to start down 5 on the y-axis, and then our slope is 2. So from that point, I'm just going to go up 2 over 1. And people usually ask, like, how many points should I put? I usually just go until I run out of space, just to be really thorough. But in Algebra 1, this was like your life for 2 months, is just graphing lines. So slope of 2. All right, which parent function is this one? All right, good, quadratic. So it's going to be a parabola. It's just that it's been transformed. So there are 3 transformations for this. I just want to review the transformations. Can someone tell me one thing that has happened to this function? All right, good, left by 2. Oh, and a reflection. Oh, perfect, you guys got them all, and down 4. So we're gonna go left 2, down 4, and then it's gonna be upside down. So we could just draw this in. If we want any more specific points, we would have to plug in more specific points. I would say let's at least like try to plug in 0 just to get another point here. If we do 0 plus 2, that would be 2. Squared would be 4, except it's negative. So -4 minus 4 would be -8. Oh, and that's like right at the edge. And then I'm going to put that reflected point over here, and then here's our parabola. And you can always get as many points as you want just by plugging in for x and getting y. And I kind of talked you through it, but if you ever just want to make a chart, like here, what if I plug in 0? What am I going to get? You can always make a chart and plug in as many numbers as you want. All right, next, this is absolute value, so it's going to be a V shape. It went right 1, up 3, so I'm going to go right 1, up 3. And then what is this 2 doing? I will tell you if we have all forgotten, but I just want to see if anyone remembers. What is the 2 going to do to this graph? It will either widen or yeah, it's one. I know you guys are putting both. Okay, that's awesome. You guys do remember. It's going to vertically stretch it. It's going to pull it this way. So it's like someone took the graph and yanked it vertically. So it's going to be a vertical stretch by 2. Basically what it's going to do is make the slope of each part of the V 2 instead of 1. So from this point, I'm going to go up 2 over 1. And so it's like a stretched out V shape compared to what the original parent function would be. But again, if you don't like that, you can always pick numbers to plug in. Like if you figured out it went right 1 and up 3, you know you're at the point 1, 3, try plugging in 0 and see what you get. This would be 0 minus 1 would be -1. Absolute value, that would be 1. Times 2 would be 2, plus 3 would be 5. And you can plot 0, 5 and get the V shape that way. So whatever your preference is for that. All right, this is the greatest integer function, and it moved down 1. So instead of starting at 0, 0, my first step is going to be down 1. So I'm going to put that point there. Now that 1/3, this 2 was outside, so it affected the graph vertically. Whenever your value is inside, it's going to affect the graph horizontally, and you have to flip them. The horizontal stretches and shrinks are kind of backwards. So instead of a horizontal change by 1/3, it's going to be a horizontal stretch by 3. So the graph is going to get stretched horizontally by 3. So each of my steps, instead of being 1 unit long, are going to be 3 units long. So let me draw in a few of them. Now, what if, let me just call this 4b. I'll just make up another example. What if instead the number was outside? So say you had something like that. Now I didn't move this one up or down, so it's still going to start at the origin. But this would be my first step. And then the next step would be 3 units apart from that. So these show like the stretches and shrinks really nicely. So this is a horizontal stretch, and this was a vertical stretch. This would be like a staircase you would not want to walk up because the stairs would be really steep from each other. And let me just look at the chat. Specific order I want to do the actions. Yes, typically, like, but here's the thing. That's not going to come up because what's going to happen is you can always just plug in a value and get a y value if you aren't sure. Yeah, the reflections come first, and then the stretches and shrinks, and then the shifts left, right, and up and down. But that's, you only really have to worry about that if you don't have a function you can plug into. When you actually have a function you can plug into, you don't need to worry about that so much. So yes, but don't worry about it. This is what I'm saying there. All right, this is exponential. So it's going to be the swoop shape. It's moved down 2. So instead of this asymptote at 0, it's going to go down 2. And then we want to get at least 1 point to plot. Without a calculator, what is the one value we could plug in for x and actually be able to do without a calculator? Good, 0. Anything to the 0 power is going to be 1. So e to the 0 would be 1. Minus 2 would be -1. So I'm going to plot 0, -1, and this is our swoopy shape. All right, this is cube root, so it's going to be that wiggly kind of shape on its side. It moved up 2, so I'm going to start by going up 2. And then I want to plot some points on either side of that, so let's try 1. If I plug in 1, cube root of 1 would just be 1, times 4 would be 4, plus 2 would be 6. So I'm going to get 1, 6. And then I'm going to try plugging in -1. Again, I just want like some points on either side here. Cube root of that would be -1, times 4 would be -4, plus 2 would be -2. So I get -1, -2, and it is going to look something like this. And the reason it's so stretched out is because of the 4. We had a vertical stretch by 4 there, but it follows the cube root shape, that wiggly kind of shape on its side. All right, this one is square root, so it's going to be the half parabola. It went left 4 and down 5. So 1, 2, 3, 4. So we're going to start there. And so since that is at -4, I'm going to try and plug in some numbers near -4. So let me try -3 and see what I get. -3 plus 4 would be 1. Square root of 1 is 1. Times 3 would be 3, and then -5 would be -2. So I get -3, -2. Now I don't want to plug in -2, because if I do that, I'm going to get square root of 2, and without a calculator, that's going to be annoying to try to graph. Can anybody come up with another number that would be good to plug in? Like we would actually get something that would work in here? All right, perfect. 0 plus 4 would be 4. Square root of that is 2. Times 3 is 6. Minus 5 is 1. So 0, 1. And we're going to get something that looks like that. All right, ln of x plus 3. This went to the left 3, so that's where our vertical asymptote is going to go. And basically, as long as you know that the natural log graph looks like that, I am happy. If you know the basic shape, we're good. All right, now we are getting into these rational graphs, which can look kind of strange. For this one, maybe just by instinct, hopefully, what does it like feel like you need to do with both of these parts? All right, good. So this one's going to split x and x, and then what else? How will we factor this? Good, 2 and 1. And if we want a positive 1x in the middle, we'll need plus 2 minus 1. And then we're going to do the same thing in the denominator. So how is that one going to split? All right, perfect. 5 and 2. And to get 7 in the middle, we'll need 5 plus 2. So both positive. So what do you notice happens here? All right, awesome. When something cancels out, that means that there is a hole there. So we need the value that would make that 0, which would be -2. So the hole is going to be at -2 something. And the way that we get the y value is just take the x value and plug it in. So if we plug in -2, -2 minus 1, that would give us -3 in the numerator. You make a note. And if you plug in -2 down here, that will give you +3. And then that is going to reduce to be -1. So we have a hole at -2, -1. And then I also just want to get the asymptotes in here. The vertical asymptote is going to be wherever this is 0. And that's just because you're not allowed to divide by 0. So the vertical asymptote is going to be at -5. The horizontal ones are tougher to get. I don't know if anyone will remember this, but what you do is you compare the exponents here, and where they're the same, you use the leading coefficients, which since they're not written, they're both 1. So 1/1 is 1, and the horizontal asymptote will be at 1. And I usually just dot those in on the edges because sometimes it can go through in the middle, but this is going to look something like this. And if you wanted more points, you can make an XY table and plug in more points. But if you know the basic shape, then you're good. All right, so for this one, there's nothing to factor. So there's not going to be a hole. Where is the vertical asymptote going to be? What is going to make this denominator 0? All right, it will actually just be 1 for the x minus 1. I know that's tricky because there's a squared on that. If you plug in -1, that'll give you -2 there, which squared would be 4. So just +1. So which is good because we don't want to have 2 vertical asymptotes because that's a lot. So vertical asymptote at 1. And then for the horizontal one, again, we have to compare the powers. The power here is 1. The power here is 2. So that's not a tie like it was over here. When the numerator is smaller than the denominator, it automatically levels off at 0, which I'm sorry, because I know when I put that on here, it's hard to see because it's on the axis, but we're going to level off at 0. And then we don't have any other points on here, so let's try to plug something in. I would just try to plug in 0. Let's see what happens when we plug in 0. If we plug in 0, the numerator is going to be 0, so it actually doesn't even really matter what's down here. That's going to just be 0. And then maybe let's try to plug in something else. Let's see, maybe let's try -1. Our numerator would be -1. Our denominator, oh gosh, what's that going to be? -1 minus 1 would be -2, squared would be 4. Okay, so that's going to be really teensy tiny, but it's going to be down here somewhere. So this is going to come down here below the x-axis. I can't really graph that at -1/4. That's really tiny. But it's going to come down here and then come back and level off at the asymptote. And then to find out where the other part of the graph is, let's just try to plug in a number over here. So like, let's try to plug in 2. Because this arm of the graph is either going to be up here or down here. I just don't know which one it's going to be. So let's try 2. If we plug in 2, the numerator will be 2. The denominator will be 1. So actually, that'll just be 2. So 2, 2, and this is going to look like this. Basically, for the rational graphs, though, if you can get the asymptotes in the right spot, then you're good. All right, nearly done. Just a couple more here. This one is, let me fold over my paper. This one is polynomial. Whenever you do these, it's good to just figure out where the zeros are. So we're looking for what would make each of these factors 0. So the first one's going to be 1, and the second one's going to be -3. And then you want to know what the right-hand arm of the graph is doing. If the graph, if the function is positive, the right arm is going to go up. If there's a negative, it's going to go down. So since I see a negative here, I know that this is going to head downwards. And then do you guys remember the pattern for the 1s, 2s, and 3s? If there's a 1, it's going to just cross straight through. If there's a 2, the graph is going to act like a parabola. And if there's a 3, it's going to act like a cubic graph, so it'll wiggle. So at the 1, which is this x minus 1 here, that's to the third. So I know it's going to act like a cubic graph there. So I just kind of made it wiggle. And then at the -3, which comes from here, it's going to act like a parabola. So when I connect to that point, it's going to look like a U shape. So this is just a pattern for how you basically connect the points. Did that sound familiar at all? Do you guys remember the polynomial unit from last year? You do that in algebra 2 as well. Is that familiar, those exponents? Good, okay. Usually once we get that pattern down, those kind of go well. All right, and then here's piecewise, everybody's favorite. All you have to do is concentrate on one piece at a time. These freak everyone out because there's 3 parts to it, so it looks like a lot. All you have to look at is this for right now. So this first part is linear. The only thing is we only want to graph it for numbers smaller than -2. So let's try and plug in -2 and see what we get. And what kind of circle will we put there? Will it be open or closed circle? Good, closed. The equal to means it'll be a closed circle. So plugging in -2, that would make this -6 plus 10 would be 4. So we get -2, 4 with a closed circle. And then we just need to go to the left of -2. There's not going to be anything over here for this graph. It's only going to be for numbers smaller than -2. And so you can plug in any number over here that you want, but I'm just going to use the slope. The slope should be 3. And we want it to be a positive slope. This line should be increasing from left to right. So this piece of the graph looks something like that. So just like a little clock hand. So that is the first piece. And now all you have to do is look at the middle piece. So sort of just ignore everything else. This is going to be exponential. I'm just going to plug in -2 and 3. Those are the endpoints of the interval. They will both get open circles. So let's try and plug in -2. 1/2 to the -2. Let's talk about that. The negative exponent is just going to flip the fraction, just is going to flip it over. So this actually becomes 2 squared. And so that will be 4. So again, the negative exponent just flips that over. It's just a reciprocal. So we get the point -2, 4, which connects right to this point. So the 2 pieces of the graph are going to match up. And then I just need to plug in 3. So if we do 1/2 to the third, that's not a negative exponent, so it's not going to flip. We just need to take 1 to the third and 2 to the third. So 1 to any power is just 1, and 2 cubed is 8. So we get the point 3/1/8, which is really teensy tiny. I'm just going to put that right there. Again, it's an open circle because we don't have the equal to. And it's an exponential function, so it should look like a swoop. We just don't have the rest of the swoop. If we did the whole graph, it would look like that. But we just got this piece of it. And then the last one's going to be a parabola. We only want it from 3 onwards. So let's try and plug in like 3, 4, and 5. And 3 will get a closed circle. So if we plug in 3, that's going to be -1 squared, which would be 1, but then we're going to make it negative again. So -1 plus 4 would be 3. If we plug in 4, 4 minus 4 is 0, so this whole entire part goes to 0. And then plus 4 would be 4. And if we plug in 5, this is going to be 1, it'll be negative. So -1 plus 4 will be 3. So let me plot those. And it will look something like that. So the graph is continuous at -2, and it is discontinuous at 3 because the points match up here, but they don't here. But all you have to do is graph all 3 of them separately. And like I said, you can always make an XY table to plug things in. Just be careful with the closed and open circles.